will never forget the first time that I saw an octopus in the wild. It was just this last summer. I was on a night dive, and we shined our flashlights on it, and it just started changing all these different colors. The most notable of which was this iridescent blue with a pale pink underlay. Today, I'm going to talk about octopus's intelligence. And before I go any further, the plural is octopuses or octopods, not octopi, because it comes from Greek, not Latin. First, I'm going to talk about their evolution of their brain in comparison to our own, and then how their intelligence evolved, and lastly, the structure of their brain today. So this is a phylogenetic tree. It's basically a family tree of all the species. It's a very complicated one, but as the branches are closer to the right, the more closely those two species are related. So if you've ever seen that image of a chimp evolving into a human, that's not exactly how evolution works in real life. There's an ancestor population that is neither human nor is it chimp, and then it splits. One of them evolves into a human, and one of them evolves into a chimpanzee. So each one of these branches represents one of those splits. So I show you this because here is the mollusks, which octopuses are mollusks. And here is the chordates, and we are chordates along with all the other vertebrates. And this is our most common recent ancestor. According to Irwin, in the last common bilaterian ancestor, the PDA is 600 to 1,200 million years old. And PDA stands for protostome, deuterostome, ancestor. We are deuterostomes and octopuses are protostomes. So this ancestor that we had is no more than a worm, and it didn't really have a brain. The reason I bring this up is because when we look at any animal that we feel is intelligent, it's usually another mammal. And our brain evolved together and then split quite recently, so we both have a similar way that we are intelligent. However, because our common ancestor was an octopus, did not have a brain, our brains evolved completely independently and thus are nothing alike. It's difficult to track this, however, because about 300 million years ago, according to Godfrey Smith and The Mind of an Octopus, after octopuses lost their shell, they don't have a fossil record, because when you fossilize, it's usually teeth or bones or shell that fossilizes, and because octopuses don't have any of those, they don't fossilize well. So, how does intelligence evolve? According to Zimmer in Yes, the Octopus is Smart as Heck, but Why? There's two main theories for why intelligence happens. The first being the ecological intelligence theory, and the second being the social intelligence theory. So the ecological intelligence theory basically just means you become intelligent for one of two reasons. One is to find food, and the other is to avoid predators. So when octopuses lost their shell, they became much better predators than they ever had been before, because they could go into all these little cracks and see what was going on in there. But this also made them incredibly vulnerable to predators. And so this image is actually a screenshot from Blue Planet 2. That ball of shells is actually an octopus that has covered herself in shells to avoid the pajama shark that's right behind her. So the pajama shark comes up and starts sniffing at the shells. She drops all the shells and bolts away, and he's just left sniffing the shells, really confused about where his dinner went. And so, if she hadn't been intelligent enough to get away, then she would have been eaten and thus not had children. And if you don't have kids, then your genetic information is not passed on. So in each generation, the less intelligent octopuses are killed off, and so each generation becomes more and more intelligent. So the second intelligence theory is the social intelligence theory. And this is where octopuses really become a paradox to us. The first part is we learn from elders. And in our own lives, we know that we start off learning from our parents, and then our teachers, and then in college our professors. Octopuses, however, are solitary their entire lives except for a very brief period where they mate. And then they also, we live a long time, because once you have developed your brain, it's extremely beneficial to actually use the brain after it's been developed. Octopuses, however, only live for 2 years. In his review of the book Other Minds, The Octopus, the Sea, and the Deep, Origin of Consciousness, then explains why this paradox is possible. Because they're so vulnerable, and yet they need their intelligence in order to live that time, their vulnerability still leads them to living for a short period of time. This other picture is really hard to see, but there's actually an octopus here. These are its tentacles, its head. My brother took it a couple weeks ago when we were diving in the Channel Islands. Okay, so now going into the structure of their brain. I want everyone to point where your brain is. It's right here, right? So it makes sense that octopuses would have a brain in the same spot. What if I told you that this is where their brains are? According to the Weak staff in The Octopus's Human-Like Intelligence, 60% of an octopus's neurons So it has a total of 9 brains, one in its head and one in its arm. This is incredibly beneficial because an arm can do things without having to get its central brain involved. So it can explore new foods or something, and it can do it all on its own. However, its central brain can still affect what's happening. In the paper Analyzing Octopus Movement Using Three-Dimensional Reconstruction, Yakatuli described an experiment where they put a glass maze above the water so the octopus could see the food, but it had to reach its arm out of the water. And so when it does that, it actually uses the sensors in its arm. So it had to use its central brain and its eyes to guide its arm through. The majority of octopuses did actually succeed in getting the food, so this proves that they can use their central brain when it's necessary. In all these experiments that we do on octopuses, it's very difficult to know if this is how they would actually react in the wild. In Learning from Play in Octopuses, Cuba explains why it's so difficult to study them. There's 2 reasons. One, when they live really deep in the ocean, and we don't have the technology to reliably study them when they're down there. And 2, when the octopus is in captivity, it's actually aware that it's in captivity. It knows that you as a human are keeping it in the aquarium. So we can't tell if its reactions to things the experiments we put it through are its natural reactions, or if it's just adapting to being in captivity. I want to leave you with this quote by Peter Godwin. This is probably the closest we come to meeting an intelligent animal. And we've explored this in 3 different ways. 1, how their brain evolved so differently from our own. 2, how their intelligence evolved and why it's a paradox to us. And 3, the structure of their brain and how different it is from our own. So, I know that you guys are not biologists, but when biologists study octopuses, they really have to open their horizons and look at them in a new way that we cannot really wrap our own heads around because they're so different. When you guys in your own lives are presented